Hello friends, welcome back to my channel on Average True. So we are planning to start new playlist that's called Engineering Mathematics. Okay, so it's Engineering Mathematics. So in this playlist, maximum we will discuss about four modules. So, okay, module one is about matrix theory. And module 2 is about basic calculus. Okay, and unit 3 is about first order ODE, means ordinary differential equations, and the fourth will be second order ODE or higher order. Okay, so maximum we are planning to make 40 lectures on these modules. So before going to that modules in detail, first of all I am saying that maximum will discuss about concepts and their applications. Okay, instead of focusing on more on problematic, we will discuss more on applications and conceptual oriented. So in coming to the way of teaching, already we have designed one website for this engineering mathematics. I will share you in the description link. So you can see there will be engineering mathematics, and if you go to the lecture chapter wise, there will be chapter 1, chapter 2, chapter 3, and chapter 4. And if you go to the matrix foundation, for example, in matrix again we have subdivided into 10 lectures. Those are given here. So lecture 1 is about introduction to matrix, and lecture 2, lecture 3 is about elementary operations, and 4 is rank, 5 is linear equations, means system of linear equations, 1 and 2 eigenvalues, Cayley-Hamilton theorem, and quadratic forms and canonical forms. Okay, so today I will just give brief about matrix, means how matrix will form and what is the use of matrix, and there are different types and basics. Maybe those things you have covered in +1 +2 levels. Okay, so coming to the lecture 1, so this is our lecture 1. So you can see that the title will be introduction to matrix, and in this lecture maximum we focused on definitions on types of matrix, what are the operations we can do by using matrices, and matrix calculator will be given. So how we can calculate addition, subtractions, multiplications, determinant, inverse, and whatever it is. Okay, so before going to the matrix and everything, first let's discuss about applications. Okay, so matrix theory is the backbone of, I can say, backbone of machine learning and deep learning. So why? Because linear linear algebra or whatever matrix theory directly won't influence machine learning models, but back end everything work done by matrix theory. For example, you can go with the deep learning model. So for example, you want to predict some images by using CNN. Okay, so for example, I have written the digit 9. Now I want to predict what is the digit that one. So how computers will read these things by using matrix array form. So they will be rows and columns. So it's nothing but matrix background, and again it will be converted into kernel, and there will be different process for CNN model. Basically, when you see the gallery, your gallery, so every image is stored with some dimension like pixels, like 1260 into 392. Some pixel will be there. It is nothing but matrix calculations. And again, when you want to merge two images, or you want to split two images, these all things comes under backend will be matrix theory. And similarly, if you see about the data reduction techniques, so data reduction, for example, you are having huge number of data, so you want to remove unnecessary columns. In that cases, you can use the rank concept by using, for example, I have taken three variables, x1, x2, x3. Now if x3 will be dependent on x1, now I can remove either x1 or x3, so it will reduce the dimension. If only 3 columns will be there it will be no use, but if you are having 100 columns, in that situation you can use rank concept. Okay, similarly when you are having system of linear equations, So system of linear equations. Equation is what? To find the unknowns. So for example, we are having a equation 2x plus 3y equal to 1 and 3x plus 7y equal to 2. Some random equations I am taking. So what is the use of solving these two equations? To find the unknowns and x and y. So these x and y's where they are coming, maximum linear equations will come from linear programming. I think so you will study those things also. Okay. Similarly, next topic, eigenvalues are there. Means eigenvalues. So eigenvalues also there will be high demand in data reduction techniques. So EVD, SVD, diagonalization, all these comes under data reduction techniques. These are the major applications by using matrix theory. So now coming to the lecture 1. So lecture 1 we have discussed about matrix and basic operations. Coming to the matrix, so what is matrix? Matrix is nothing but an array with rows and columns. Okay. So generally we use the capital letters A, B, C and so on. So what is the mathematical represent? For example, I want to write A I Z. So there will be A11, A12 and so on, A1, N columns and A21 and so on, A21 and so on, M rows and so on, AMN. So this is nothing but matrix representation. So we can use square brackets or curly brackets or parentheses, whatever it is, your convenient notations you can use. There is no wrong in that. Coming to the, for example, A equal to 1, 2, 3, 4. We can see here rows and columns are equal. So it is nothing but square matrix. And for example, we are having B 1, 2, 3, 4, 5, 6. Here you can see 2 rows and 3 columns are there. It is nothing but rectangular format, rectangular matrix. And similarly, so when you are having only one column 1, 2, 3, so it is nothing but column matrix. And similarly, B is equal to 1, 2, 3. In the row wise, it is nothing but row matrix. Similarly, there are so many matrix forms are there. For example, square, rectangular and row column is done. Coming to the what are the forms will exist. For example, diagonal matrix. So diagonal matrix is nothing but only diagonal elements will be there, rest of the things will be 0. And similarly, scalar matrix. So scalar matrix is nothing but diagonal elements should be same. Okay. And rest of the things will be 0. And similarly, if we come to the identity matrix, everyone know that I think so. Identity matrix is nothing but diagonals will be the 1 and rest of the things will be 0. Okay. Next, coming to the upper triangular or lower triangular. Upper triangular is nothing but you can see here upper triangular is forming, here things will be 0, rest of the things some values will be there. And similarly lower triangle is nothing but here. Okay. So next, trace of a matrix. For example, you want to calculate the trace of a matrix 1, 2, 3, 4. It's nothing but sum of diagonals. Okay. And similarly symmetric matrix. Symmetric matrix is nothing but A transpose equal to A, and non-symmetric matrix or asymmetric matrix is nothing but A transpose equal to minus A. Transpose is nothing. What is transpose matrix? Interchange, or for example you are having 1, 2, 3, 4. Just interchange into rows into columns and columns into row. It is nothing but transpose matrix. Okay. Next we are having involuntary matrix. Involuntary is nothing but A square equal to A, and nilpotent matrix, and no, nilpotent means is A power n equal to 0. Here whatever power is getting, that is nothing but nilpotent. And some more like singular non-singular. Singular is nothing but that equal to 0. If that equal to 0, we can say it is singular. If that is not equal to 0, then we can say it is non-singular. Okay, these are the major types will exist in matrices. You can go to that lecture also, you will get so many in detailed definition. Let's say here it is definition will be given on mathematical form, and this is an example. And coming to the type square, rectangular we have done already, diagonal, square, identity is done, and zero matrix is nothing but zeros, rows and columns are done, symmetric and asymmetric or skew symmetric. So upper lower done, transpose is done, trace is done. Orthogonal is nothing but A transpose equal to I. So A transpose equal to I, we can say it is orthogonal matrix. Okay, next coming to the operations. What are the operations we can do by using matrices? So majorly we can do 4 operations we can do. So what are those? Addition, you can, for example, you are having A and B matrices, then you can do A plus B, and you can do A minus B, and AB, and A by B is nothing but A into B inverse. Okay, so for here some rules are there. For example, you want to addition the two matrices, their dimension should be the same. For example, you are having A as a 2 cross 3, B also should be 2 cross 3 for both addition and subtraction. Coming to the scalars, means for example addition and division. For example, we are having A matrix as a 2 into 3 and B matrix as a 3 into 2. Their columns, means column number and row number of the next matrix should be equal. If these two will be equal, then your output matrix will be like this. So let's see some examples. For example, we are having A equal to 1 2 3 4 5 6. Okay, and B equal to 3 7 9 1 2 0. Now if you want to do the addition, it is same for A plus B equal to, you can add this entry to here. So 1 plus 3 4, 7 plus 2 9, 9 plus 3 12. Here 4 plus 1 5, and 5 plus 2 is 7, and 6 plus 0 0. It's nothing but doing additions from here and here like that. Similarly, subtraction also will be the same. So when you want to do A minus B, I am writing here 1 minus 3 is minus 2, and 2 minus 7 minus 5, 3 minus 9 minus 6. So 4 1 3, 5 2 3 6 0 6. This will be your A minus B. Similarly, if you want to do A cross B, means A multiple B, here you can see the range 2 into 3 and 2 into 3. So these two are not equal, we cannot do multiplication here. So let's see one more example related to multiplication. Let's say we are having A matrix A 1 2 3 4 and B equal to 4 5 6 7. So when you want to multiply both, you can just in this direction and this direction. 1 into 4, first element and first element 4. Similarly 2 into 6 12, and again same for 1 to 2 5 7. 1 into 5 5, 2 into 7 14. Similarly here 3 4 to 4 6, 3 into 4 12, 4 into 6 24. Similarly here also 15 plus 7 4 is 28. Just to do the additions, then you will get AB matrix. Okay, similarly whatever it, if dimension is 1 2 3 4 5 6 and 7 and 8, and again 4 2 3 1 2 3 2 4 3 6. For example 3 cross 3, procedure will be the same but calculation will be difficult. You need to practice. When you practice more questions, you will get very easily. Okay, nowadays you can use calculator, so much of calculators will be there. Okay, so this is about B, means addition, subtraction, multiplications. Coming to the determinant, so determinant is possible for only square matrices. Okay, so for example you are having a matrix A B C D, then you use the notation like modulus, then formula will be AD minus BC. If it is equal to 0, we can say it is singular. If it is not equal to 0, we can say non-singular. Similarly, when you are having 3, for example 1 2 3 4 having your matrix, then determinant is nothing but 4 minus 6, it is nothing but minus 2, and the determinant range will be minus infinity to plus infinity. It is not like only should be positive, only negative. It is, there is no rule like that. Okay, And coming to the 3 cross 3 matrix, how to calculate that, it is very important. For example, you are having ABC, DF, GH, right? So now you want to calculate that for this. So you can select any row, any column. For example, I am selecting this column to calculate the determinant. Okay. So before that, first you need to aware about what is cofactor. So cofactor is nothing but minus 1 whole power I plus j into aj. So here, when you take 1 as 0 and column, you will get minus 1 whole square plus, and here minus 1 plus 2, it is nothing but minus, and again here plus, again here minus plus, minus will be there, and plus minus plus. For example, I am taking this column to calculate the debt. For example, first I need to multiply a into, forget about this corresponding row and corresponding column, then what you are having, EF, EHA. So 2 cross 2 determinant. And again here minus d multiple of, forget about this row and this column, and BCHI determinant. Similarly G. So again when you eliminate these things, you will get BCEF. Just multiply, and again here formula will be the same, EF minus HF, that formula whatever it is, AD minus BC will be the same. Let's see one example for our 3 cross 3 matrix. Let's say we are having 1 2 3 1 0 1 0 2 3. So this is your matrix. So if I can take first element 1, then there will be 0 1 2 3, it is nothing but minus 2. And similarly when I will take for plus 1 means minus 1 here, so 2 3 2 3, it is nothing but 6 minus 6 0. I no need to write this one also. And again plus 0 multiple anything is 0, so it is nothing but rank will be minus 2. Okay. And similarly when you are having upper triangular matrix, lower triangular matrix, you can just diagonals, some properties will be there, just multiplication of diagonals will be the determinant. Those things you can refer your books also. Okay. Next, inverse. So inverse of a matrix for 2 cross 2 will be the simple. It is nothing but A inverse equal to 1 by right A and cofactors dA minus B minus C. So inverse of matrix is possible for only non-singular matrices. You can see if that is 0, it is nothing but infinite. So let's see to one example. Let's say we're having a matrix 1 2 3 4. Then we want to find the inverse. So how will calculate? 1 by that 1 by 4 minus 6, and interchange the dA and apply minus signs to these two. So it is nothing but minus 1 by 2, 4 minus 2 minus 3 1. Okay. So when you are having 3 cross 3 matrix, again let's say we are having this matrix. So first step is you need to calculate that. So when you take first row, because here 0 element is there, or else I can select C3 also, it will be the simple. Why? Because 2 zeros are there. So here plus, and here minus, here plus. Again I will get 2 multiple 1 minus 2 minus 1. It is nothing but minus 2. Minus 2 will be the determinant. Now I need to calculate cofactor. Cofactor for each and every element. So cofactor again 3 cross 3 matrix you will get. So when I am calculating cofactor for 1, I need to forget same determinant concept, but we don't multiply this 1. So 2. Again when I select for 2, here 2 2s are 4. And when I select 0, and remember that if 0 is there means 0 multiple will be there, 0 it's not like that. So when you calculate for 0, 2 minus 3 minus 1. Similarly again 2, when you calculate for 2 you will get 4. So and again when you calculate for 1 you will get 2. And again when you calculate for 1 minus 6 minus 5. And again 3 means 0. 1 means again 0. Again 2 means 1 minus 4 minus 3. Okay. sorry, here if you observe the date here, 2 into 1 minus 4 minus 3, it will be minus 6. Okay, calculations you need to do carefully. And again, so coming to the inverse, minus 1 by 6 cofactor is transpose of this thing, it will come here 240 420 minus 1 minus 5 minus 3. It is nothing but inverse of your matrix. Similarly, if you are having 4 cross 4 matrix also, procedure will be the same, but calculations will increase. So maximum lecture 1, those things only are there. And basic operations, you can see a plus b and a minus b, a cross b, and determinant. And inverse of a matrix, how to calculate inverse. And then determinant, then there will be calculator, you can apply here till how many rows and how many columns you want, then you can give the matrix. It will give either you want addition or subtraction, multiplication, determinant, and join, or if you want to clear the matrix, you can clear. Okay, this is about lecture 1. If you have any doubts in that, you can comment us. Okay, lecture 2 will be echelon forms. Okay, thank you.